Hi, everybody, and thanks for attending today's webinar, Zero Trust, Endpoint Security with Chef InSpec, a modern approach to compliance hardening. I'm happy to introduce today's speaker on this webinar as Jeff Vogt, Solutions Architect here at Chef. So before I turn it over to Jeff, I have a couple of housekeeping items to cover. If you have any questions, you can submit them through the Q&A button at the bottom of the screen at any time, and we will be answering questions at the end of the presentation. For the best viewing experience, we recommend closing any additional programs or browser sessions running in the background as webinars are bandwidth intensive. And finally, this webinar is being recorded and an on-demand version of the presentation will be available by tomorrow. So for those of you just joining, welcome to today's presentation, Zero Trust, Endpoint Security with Chef InSpec, a modern approach to compliance hardening. Let's go ahead and get started. Jeff, over to you.
Thank you, Erin. So hi, everybody. I'm Jeff Vogt. I'm a solutions architect at Chef Software. I've been at Chef for about 3 years in this role. Prior to that, I've had a pretty long career doing configuration management for larger businesses. I was selected to do this webinar because a number of my customers are doing zero trust patterns at their organizations, and they're using Chef as part of their strategy to actually do some config management on laptops and do compliance validation, which they use in the zero trust flow. So I work closely with our product teams, our engineering teams to help align our roadmap to some of the solutions that our customers are starting to deploy. So what we're going to talk about is, I'm going to give a pretty high level brief of Zero Trust and Beyond Corp. So those are a couple names, they're pretty interchangeable. But they're the patterns that these companies are using that are sort of on top of typical things like SSO and VPN. And then I'm going to cover how Chef fits into the world of desktop management, which is kind of a key component of Zero Trust. And then we'll get into a little bit of technical solutions. And if I have a demo, we'll get into that. And then we'll have time for Q&A after everything. Go ahead, post questions as you need them, as they come up, and I'd be happy to answer them if they're not super piled up between sections, but I'll kind of lean on Erin to take care of that for us. So let's get started here. So just to kind of get everybody foundationally on the same page, I'm going to cover some things that are pretty straightforward, pretty simple. But I wanted to make sure that we're all foundationally in the same place. So yeah, at our businesses, we have stuff, right? There's things we need to connect to on a daily basis. And some of those are super business critical. Some of those are super operationally critical. Some of them are a little bit, less secure or less important to really lock down access to. So we want to think about patterns that allow us to have varying levels of authentication, right? So you might have a email file share, you might have to SSH into production databases, you might have some business operational tools. So all those have kind of varying levels of criticality. So everybody needs a pattern to reach that. And the simplest, most traditional pattern is you plug into the wall at the office and you've got access to everything you need. And, that's been the pattern, for years and years and years. Obviously, nowadays, we're not allowed to go to work. So, there's got to be a better way. The better way is not running a cable to everybody's house, but we can sort of virtualize that with something like a VPN. So a VPN, which I'm sure most people on this call have experience with, is just a tool that lets you pass a username and password to a tool that runs a client on your machine, and it creates a virtual network. And that virtual network is sort of bridged to the internal network that lets you access all the things that you would have had if you're in the office and plugged into the wall. So once you do that, then your users are happy and you kind of go on with life. We've also we've seen like a relaxed view of this model where maybe not everything is on the internal network with SaaS platforms and things like O365 or Google Apps. We move things like email and calendar outside of the internal network, and we access those most commonly with some sort of single sign-on tool. So this is, an authorization system that, lives maybe on your network, but to access the email provider, there's an API system that lets your username and password be validated without having to go connect to the VPN. So to simplify this out, some of the pieces of getting connection to our super critical, important business apps are employees have multiple devices sometimes. And then to reach these business apps, we typically have multiple connections. So, we're either in the office plugged into Ethernet, we're using SSO, we're using VPN. And this is where the word trust comes in. So obviously this whole webinar is titled Zero Trust. It's on the topic of zero trust. What's the trust assumption for the traditional model of access? Well, either my employees are allowed in the building or their credentials are valid when they're connecting over SSO and VPN. But there's some risk factors here. And these are the risk factors that Zero Trust and BeyondCorp are meant to completely address. Number one, on the employee side, if my credentials are stolen because I wrote them on a sticky note, there's no way to validate that the actual human that's typing those credentials in is the person that was issued those credentials. Furthermore, we often see things like, it takes 2 weeks to onboard somebody. It takes 2 weeks to take them out of the system as well. So if you have a disgruntled employee, or even somebody who doesn't realize what they're doing after they leave their job, they may still have access to your system. From a device perspective, it's kind of funny because endpoints, workstations, laptops are actually probably the largest unaddressed threat to our internal networks, because these are devices that move in and out of the building. They go into coffee shops. They're used by super power users all the way down to, people that this is their first laptop. And we typically do require some sort of installation of antivirus or patching, but in my experience, the deployment rate or effective rate of those tools actually running on a regular basis is pretty minimal. So it's been noted that the device compliance status is probably one of the biggest growing risk factors. So those devices, we're not really measuring the health of them from a compliance and security perspective. We have no way to prove that the devices are company owned or not. And we've got really no way of protecting against somebody tailgating or essentially getting into the building without a badge and plugging into the wall. So when you hear about zero trust, we're going to be kind of covering why we just straight up don't trust the device and we do validation at the point of access. So what's the magic? How do we actually solve those risk factors? It involves putting some additional logic into our authorization flow that sits between the typical auth that we've enabled and the business apps that we're trying to reach. And that pattern is called zero trust. So some history. Zero trust is a term that was coined about 10 years ago, and it came from Forrester Research. And it was based on some leaders in the IT industry and some of the patterns that they were starting to do to effectively enhance their network security beyond username and password. And then BeyondCorp is a implementation that Google has developed on their own. And they developed it kind of in parallel to John's research at Forrester. But it's effectively the same principle. So it's about using an access proxy that knows a little bit more information about the device. And Forbes has said, never trust, always verify. That's a phrase that we tend to see a lot in security in general, in SecOps. But it fits the model here. And there's some old kind of patterns of joining from a domain join laptop That's pretty much all you used to need in the past. Now we're still going to validate that you're running security software, your laptop's configuration is in place before your laptop can be logged in or connected to that resource. So let's look at Google BeyondCorp as just a reference. I think that they have a very nice diagram that describes the patterns here. So number one, the employee, again, has a device, and to access any of those cloud resources, the device must go through a rules engine and a proxy. And they split out those parts, but those really can be the same component, because what we're really establishing here is a rules engine that does a little more than just validate username and password. So what can a rules engine do? Well, we can validate device ownership. We can check the patch level of the machine, measure device security compliance. We can validate employment or credentials. Really, the list of things that your rules engine can do is up to you, because that's code that you can usually author or augment inside of your existing auth system. So, what are some examples, some real world examples of how we might use a rules engine to allow access to certain things? So let's take a look at a sort of less critical business app of email. So we might develop a system where for my device to reach email, we just have a simple set of rules. We want to validate that the credentials that the employee has are correct and that it's a company-owned device. Maybe we don't necessarily care that like their antivirus definitions are up to date if they just want to read their email. We can have a pretty relaxed policy in this case. If we maybe wanted to do something like SSH to something, this is kind of a little more complicated. Modern SSH, especially in the enterprise, does not use username and password. And it doesn't necessarily even use a public-private key that lives for a long time. We often see certificates that are signed by a certificate authority that are generated and only last a few hours at a time. So to access those most sensitive resources, we often need something like some sort of service that can generate these one-time use certificates. And usually that's done through a credential-based system. So what if we improve that system to do some additional checks? Number one, obviously check credentials. Number two, check it's a company-owned device. But maybe we only allow access to generate those certs if the device is patched. So, that's sort of an enhanced model on top of what we've done for email. Continued into this path, we still need network access to that machine. And network access is a little bit more intense than having a credential because, a credential definitely proves that I have access to the machine, but we also need to protect against, that destination machine maybe isn't patched and maybe has vulnerabilities. So this is kind of where you might have two layers to this. So I've got my credential, I've got my certificate, and now I need to get on the VPN to reach that node. So this is where we can add some additional checks. So this might be where we measure that the device isn't just patched, but the device is CIS compliant against a CIS benchmark, which is an industry standard benchmarking company, which actually Chef has a relationship with. And I'll get into that in a little bit. But we might validate that, the disk is encrypted, the screensavers are correct, the timeout, the correct amount of time, they have passwords. We might also check the AD to make sure that the user is in some AD group that grants them access to, the VPN. So you can imagine having multiple types of policies that allow us different levels of access. So who are some vendors that are in this space for zero trust? Number one, Okta is pretty common. We see that the caveat there, and maybe I could say we're trying to work on this by building a relationship with them, is the device checks that they do are limited to the device checks that are in their agent that would actually run on your laptop. And there's no way, from my knowledge, and I could be wrong, but there's no way from my knowledge to augment those checks to do things that might be specific to your organization or measure against a full benchmark like CIS. Google has obviously their Beyond Corp model, and it works very well, but it is in the Google ecosystem. And again, it doesn't allow you to do arbitrary types of tests against the device context, measuring a arbitrary amount of compliance data points. Microsoft and Cisco have Zero Trust and SAML products that do a lot of authorization things, and they are extendable. Although it's the UX around extending to the point of maybe reading some data from the Chef ecosystem. We're trying to improve some UX around that, so we're working with them as well. All right, so review of Zero Trust versus traditional auth. Number one, traditional auth. Major risk factors, we don't protect against the state of the machine, being, possible to introduce vulnerabilities to our network because of such a broad trust model. We can do two-factor authentication. We can do device certificates, but we cannot do any device context measurements. So Zero Trust is effectively a way to intercept any authorization attempt and run arbitrary tests that take in as much device context as possible and allow us to do basic compliance level checks against that machine to make sure that it's actually up to the standards that we've set in our organization. Okay, so next, this is a little bit more from a Chef perspective. So we've, like I said before, we have some customers that use Chef for desktop. Actually, there's a lot of companies out there, and there's a very big community of people that do that. I'll get into who those are in a little bit, but right now I want to cover one example, one customer example. So we have a few products. The ones I'll focus on here are Chef Infra and Chef InSpec. If you've heard of Chef, Chef is the tool to do config management. That's traditionally what people know us as. We also have a tool to do testing against config, and that's InSpec, and that's actually turned into quite a strong, mature compliance testing language. So the way Chef fits into this flow is if Chef manages your laptop, or at least measures the compliance state of that laptop, we now have a rich set of data that we can use in our rules engine. So device is talking to Chef back and forth, doing continual hardening, and then doing validation of compliance level. And that state is always kept up to date whenever that node checks in. And that's the data that like a rules engine is going to pull from to make its decisions about whether or not that node should be allowed to access the resource. So here's an example of what a customer has built. And I think that this is, in my opinion, shows kind of the ideal, shows all of the pieces that you would need to get this right. So we have our user, and this is where I joked about this earlier, but this is where marketing kind of leaves off and Jeff's diagrams fit in. It's much less pretty. But we've got a user who has a laptop and they want to reach a service. In our example, let's call the service production database. So we've got this intelligent proxy. The proxy gets a request that the user with laptop X wants to reach prod database. So the first thing it does is it contacts this access control engine, which is the main logic engine that can do everything to make this determination. So number one, this access control engine is going to first gather an access policy for production database. So you can imagine a database of policies, and production database is a very sensitive resource, so it might pull in a policy that is very restrictive. And then what it does is it leverages any number of data sources to validate that access policy against the user and the type of request that they're trying to reach. So they might reach a corporate directory, and then there might be some other sources of device context. In our customer's example, they use Chef to harden and validate the compliance of their laptops. So Chef is their #1 source for device context data. And if we look at what their policy is, we can understand how they're using this type of data. So their policy is, okay, #1, we want to know that Chef client checked in within the last hour. But #2, which I'd agree is probably more important, we want to check if the compliance profile, and maybe this might be some restrictive InSpec profile, pass within the last hour with 0 critical failed controls. And only then, and I guess is the user and the DB admin's AD group. But that might be what the policy is. But only if all 3 of these pass does the access control engine give their thumbs up to the smart proxy, allowing access to the service. So you'll note that we're not actually invoking a test on the node in real time. We're using historical data. And that's mostly to stabilize the process and speed it up. But really your data sources are kind of up to you how you want to organize and orchestrate those. So I think it's a pretty good example of a compliance-based authorization model. So what I've got here is a comparison of different auth strategies. On the left, this is going to be sort of your peeling the onion back. So at the very base level, you can only plug into the network. The next one might add, authentication over VPN. Then we might add 2-factor. Then we might start deploying certificates to validate device ownership. And then the final sort of level of that onion is full compliance gated access, which includes all of the above. So some of the things you'd think wired access is an actual, that's really secure, but we've got no way to know that those laptops are not have vulnerabilities or if they're patched. We don't know if the laptops in our building came from our IT organization. Obviously stolen credentials, sticky notes, we all know that problem. So you can kind of see as we start layering in more and more pieces, this is where you start to get benefits in all of the main categories that Zero Trust supports. So review on this, we've got tools that let you enforce and measure device compliance. And these are industry standard tools. They come from the data center. They are used by a number of large companies. I think last time I checked, there's around 250,000 laptops in the world that are managed by Chef. And a lot of those are in the Bay Area with some of the more well-known brands. Compliance gated access, that's really just being able to measure the device's compliance score during every authorization attempt. And access policies are those rules that define, the level of like sort of the score that the machine must have. And if I'm going to allow it to access something, and that access control engine just really ties together the request, the access policy, and then the device context and user data from whichever sources you want. Okay, moving on, and I think we're making pretty good time here. So this is going to be a dive into some technical solutions. So first of all, I'm going to give some basics of Chef Infra and Chef InSpec, and then we'll get into how people are using Chef and InSpec on their machines to actually do desktop management. Then we'll kind of tie it all back to Zero Trust because I've got a demo that shows how we use this data sort of in real time. So this is probably review for a lot of people that are on this webinar, but the building blocks of Chef are these atomic pieces of configuration called resources. The idea of a resource is we take a lot of the code that it might take to manage, creating a user on many different operating systems and OS versions. And we simplify it down to, the idea that I need to manage this user and some data about it, maybe create it or modify the group it's in and so on. and forgive me, these docs come from our server documentation. So these aren't really things you do on a desktop, but well, users, yes, but maybe not a web server. But kind of the idea behind Chef and the reason that people use Chef instead of just writing a lot of scripts is behind the scenes, in addition to supporting multiple operating systems for the large amount of resources we have, it's going to check the current state of the machine, and it's only going to do work if your desired state is different from what the machine state is. So, you know, it's very nice to, you know, create this policy and run it, and you know the next time you run it, it's not going to change anything, which makes things very stable. Also, I'll mention recipes. That's just a collection of resources to kind of accomplish a similar goal. Very commonly, we're doing things like managing software or features, and then, you know, templated files, usually config files, and managing services. Something that I don't have slides for is the rich ecosystem of Mac OS and Windows desktop resources that Chef has, as well as the community have written to manage common things like you know, screensaver, timeout, disk encryption, firewall, all the things that you might care about for desktop. But if you want to reach out to me after the call, I can walk you through some of those. And I do have some links at the end. InSpec is a compliance measurement language at its most mature state, but really it's a testing language. Its original iteration was really just a way to define something like a Chef resource, but in a read-only mode. So the comparison on the left here is, say I wanted to test for some key inside the SSH config. I could use Linux tools like grep and sed to get a, you know, pass or fail. But we really want to make that a little bit more robust and work across more operating systems. So in the InSpec side, we turn that into a resource that knows based on operating system where the file is, what the format of the file is, and so on, and lets us use some nice comparators to you know, define what our test should be. And then when I talk about compliance, that's really saying you've got a test that now has some additional metadata like the score or impact, and maybe some human readable information, which is useful when, you know, we actually have a failure and maybe our help desk is, you know, trying to solve some employee issue. Well, maybe if your InSpec is in a very good state, they can read the actual failure and understand immediately what's going on that machine. And then the last thing is a little bit more of a pitch for, you know, becoming a commercial customer with Chef. So Chef Automate is the data store where all this data goes. And one thing that we include as a customer who's using Chef Automate is these subscriptions to a number of industry standard security benchmarks. So we're certified with CIS, who's arguably one of the biggest, and they release new benchmarks every quarter. And we take those benchmarks from their reports and convert them to InSpec, and then give them to our customers as part of their subscription to Chef. So out of the box, you can take a CIS benchmark for Windows or Mac OS and run it against any machine that is in your Chef ecosystem. So this is a really nice, you know, just easy beginning to Chef. Then this is a super busy slide. I'll make it quick though. The typical architecture here is I've got nodes, and on the desktop space, I've got laptops mainly, but I might have some servers as well. The servers connect to the Chef server. The Chef server tells the node what their policy is. The policy might be something like, you know, some level of, you know, compliance hardening, plus maybe deploy some software that maps to what type of user you are or where you are in the org. And then when the node is done, it sends back all the data about what it did, as well as any compliance reports if there were any compliance tests. That data is shipped to Chef Automate, where it lives and is stored for auditability, as long as you want to, you know, for as much disk space as you have, really. So, I know a lot of standards say you need 6 months of data. If you provision enough disk, you can hang on to that data. From there, it's all accessible over API, and this is where your access control engine might actually, gather device context. And then there's dashboarding tools built in that I know that we're releasing some desktop products at ChefConf coming up this year. And the hint there, which I'll probably get in trouble for, is that there will be a desktop dashboard as well. So some specific desktop related views of your data. So that's coming. And then the way we actually put data into Chef Server, meaning like cookbooks and InSpec profiles, is we author them on our laptop, we do local testing, we have a pipeline that can push that code to the Chef Server, and then it's available. Okay, kind of nearing in on the end here. So Chef for Desktop is the, that will soon be the name of the product that you can actually buy, although we do have some desktop SKUs. But when you think about companies that are using Chef for desktop, that's what I'm going to focus on here. So probably the biggest sort of logo everybody would recognize as a very large, successful IT company is Facebook. We've had a relationship with Facebook for a very, very long time. They use Chef all over the place. They use Chef to configure all of their laptops. They have over 100,000 laptops under management with Chef. And it's a team of 6, which is unbelievable. So they're very successful. They've built a huge community of people who are using Chef for desktop management. I'd say about half of them are either doing some zero trust patterns or are implementing them kind of as we speak. And it's a great place to go if you're very interested in the idea of compliance gated access as part of your zero trust deployment. And we participate in those communities as well, so you get access to Chef engineers as well. Slack is another company who uses Chef. They have another huge number of laptops. I can't say how many, but they've been using Chef for a long time. And then, of course, we eat our own dog food, so all of our Chef laptops are managed with Chef. All of these companies and more, who I can't give names to, they all interact with us and product and engineering and are highly influential in determining where our roadmap goes. And if that's something that you like to have out of your vendor relationships, know that we live for it. So it's a pretty nice add-on to being a customer of Chef. Okay, so how do they use it? Where does it fit in? So in this slide, I'm going to talk about zero-touch provisioning, MDMs, provisioners from your NDM, and then the agents that your provisioner installs. So let me just do a little glossary. Zero-touch provisioning, that's the idea that I'm going to have a new employee start on Monday. Let's just have the new laptop shipped directly from Apple or Dell or Lenovo. And on that laptop is a pre-installed MDM that knows what organization the laptop belongs to, and that's it. Doesn't know anything about the user. So an MDM is a mobile device management platform, and it's critical for managing desktops and other like mobile devices. But basically, it's the key to connecting that laptop back to the organization and then also to the user. So it kind of bridges that gap. So device arrives from Apple, user opens it up, types in their credentials, the MDM basically accepts them. And that's kind of where the MDM kind of stops doing a lot of work. At that point, the MDM will install a provisioner. If you don't use Chef Infra to do config management, you might have other tools, or you might just deploy some scripts. If you don't have a lot of laptops, scripts are kind of reasonable to deal with. So that provisioning is going to basically do, lots of configuration on that laptop to kind of make it into, some Acme Corp laptop. Part of that process is going to be installing agents and configuring update systems. So if you're using Chef, you're going to probably install, like on Windows, a WSUS agent, manage software updates on the Mac. There's tools out there to manage applications. They're called Monkey and Gorilla. And then you're probably going to do things like deploy some internal CAs for internal signed SSL and things like that. But then at the point, and this is kind of like we use this term a lot internally, or this quote from John, who does all of our IT. He says, from the second the device is in your hand, it's already provisioned. And from that perspective, as soon as that provisioner is done, that laptop is identical to every other laptop in the field, or with exception of user data or customizations that might be per role. But it's got all of the agents that are required. It's in the MDM, so it can be remote wiped if it's stolen. And that happens so rapidly that the user experience just sort of goes and starts working. And what's going on is the node checks into Chef, gets its policy, does its work, reports back, and that loop just happens, on interval every 30 minutes or every hour. And all that data that gets generated as part of that process is accessible over API to any of your auth systems. Another benefit to using Chef for config management is, it's rooted in the data center, it's rooted at scale. All of the people that work on Chef, if they're doing it correctly, use things like GitHub or any sort of source control provider to allow them to iterate on their cookbooks or InSpec profiles in a collaborative way. So that means using branches, pull requests, having a history through commits of every change. And there's always an SDLC type of pipeline to these successful Chef organizations. So they might use a Jenkins to do automated testing, gradual delivery. And again, all of the history of everything that goes on with all their change management from a desktop follows those classic SDLC patterns. It's all auditable. We can do, rolled out deployments, canary environments. On the Jamf and group policy side, it's very difficult to do anything from a SDLC perspective because at some point you're taking a script, even if it was tested, you're taking that script and having to upload it into one of these tools. And we find that that happens at any sort of beyond minimal scale. People are having to do that with these tools like Jamf and group policy. Last thing I want to show is the pattern of having role-specific policy. So if you've defined a baseline in Chef that does everything that you require to make that node compliant, we can do things like have a special override that's just for the engineering org. And the way Chef cookbooks work is inheritance is very key to how you do Chef. So you might develop a cookbook which inherits baseline and then maybe turns off firewall, does not install Office, installs VS Code, adds some SSH keys or things like that. And then this is a pattern that we often see at these larger organizations using Chef is they can have overrides that are based on device serial number or username. And so this is, because it's all open source internally, a user can just add an override for their machine, submit a PR, and now it's part of the cookbook flow. And this allows the user to customize what's on their laptop. And Facebook has, they've gotten this down to a science where if you know how to do a pull request, you can do it yourself. But if you have a request and you don't know how to do that, the help desk can do that. And it's very fast. It takes, it takes the person at the help desk a few minutes. And now not only was the request handled and the PR approved, but there was a full history of who requested it, who made the change, and who approved it. And then that gets all compiled together as a policy. And if you are familiar with Chef, policy files are the best way to deliver Chef code. And what they allow for is every time anything changes underneath, we kick out a new build of the policy, and then we can deploy that build through a typical SDLC environment. So you could have an integration environment, canary, production. And then InSpec is sort of critical to kind of pair with the role. So it's very easy to do the exact same thing. If I have an engineering chef role, chef infra role, then I can have a chef InSpec role as well for the engineering org. And it's really just an assembly using inheritance of a CIS benchmark plus a baseline plus role level tests that validate that that engineer laptop is set up correctly. And then we usually just tie them together at runtime. So the data that comes in when we release a new version does not have any false failures or anything like that. Okay, so just about to do a demo here. The things that I wanted to kind of review on though are, first of all, the biggest differentiator for Chef versus some of the tools out there is we are born in the data center. We come from DevOps. We can do really cool things like if you change any of the code that's going to be targeted to one of your laptops, your pipeline can execute your InSpec code before allowing that change through. So if somebody who wasn't familiar with the organization policy decided, nah, we don't need disk encryption anymore in our laptops, they make a commit, they make a branch, they make a commit, they push to the pipeline, and then the pipeline will immediately reject it because it's going to spin up a test node, execute InSpec on it, and fail a critical fail control. So that's really important to take away from this pattern. And that's the exact same InSpec profile that's running on the production laptops that you're using as part of your zero trust flow. That's kind of the biggest differentiator, is that we operate in this SDLC pattern. Okay, so I'm going to try to do a little demo here. It is kind of short and sweet, but I just wanted to kind of show. That's interesting. My background went away. It's just blue. So I've got a little demo node stood up here, and I'm currently just logged in as a user vagrant. And what I want to do is log in to or become root on this node. So if I try sudo su, and this is what's going on here, is this is a new version of CentOS and a new version of sudo that lets me write plugins in Python for the sudo command. So I wrote a plugin that can hit the Chef Automate API, which my machine is registered to, and let me do something very cool, which is control access to commands at runtime on a or on a critical server. So you can see restricted command, checking against production compliance policy. Your machine is not compliant. And so we can log into Automate here and see, well, what's going on this machine, my laptop. So there's only one node in here. Oh, and it's my laptop, and it's not compliant. And I'm only running one test because it's a demo, but wow, God, I didn't realize turning off that screen corner, which is a real CIS benchmark, but I turned that off, and now I'm failing a critical failed control. So let's remediate that. So we'll go back to hot corners, and oh man, let's turn that back on. So now I've got the ability to start a screensaver by going to the corner of my screen. Whew, that was close. So I'm going to invoke a InSpec test manually. This is something you'd run kind of as a service, but it's just running that test and then reporting back to my Automate server. So now on my Automate server, I can see, okay, cool, I'm passing that control. So let's just go back and try to log in as sudo. So boom, there you go. So checked against production compliance policy. My machine now meets production compliance, and I can do all the awesome things, right? So that was just a quick demo. of how you might leverage compliance data as part of your organization's security policy. So that checked my laptop before it let me access that command. Okay, additional resources. We'll get a deck out or a blog out to everybody who attended, but we have some great resources for learning Chef. We have links to the Facebook IT community and the Mac admins community, as well as a blog from Okta on Zero Trust. And then, just some kind of value summary here. So, probably the biggest value is that reduced risk. So we know our laptops are compliant. When they try to access something, we can reject them if they're not. And the whole world of InSpec and Chef, the whole world of InSpec and Chef being in the pipeline makes it very easy to author and test changes to your Chef and InSpec code, to where our successful customers are often patching or testing against 0 days in less than an hour, and writing and deploying patches in less than 3 hours with full testing and confidence in their deployments. And then some other cool things that customers are doing. This is a Facebook thing. Because InSpec has to run locally on the machine, it can also dump out a report to that machine and let they do some cool things with that report. So they have a tool, they've actually open sourced it, that will alert you if your machine is not compliant. First, you'll have a blinking light in your menu bar, then you'll have a pop-up, and then you'll have a full screen takeover that says, you need to get this laptop in for support. So there's things we can do that just vastly improve self-remediation percentages, which kind of reduces the overhead on our help desk. So yeah, I wouldn't say it's a reduction in team size in these teams, but because no one ever really loses headcount, but by decreasing the amount of time it takes to do endpoint management or help desk tickets, that's where you can innovate in those departments instead of just catching up to today's tickets. We can actually start innovating in those departments, and I think that's a really big benefit. And then Aaron, did you want to kind of close us off with ChefConf and any questions that have come up on the call?
Yeah, so let's just start with some questions here. We'll leave ChefConf up after, but we will start answering some questions. If you do have any questions, feel free to submit them now, and we will get started on some here. So one question here, is Chef and InSpec open source?
So yes, so Chef and InSpec historically have been open source, including our builds, and you can use all of the source code is Apache 2, but about a year and a half ago, or maybe 2 years ago, we started making our builds something that require a commercial relationship. So I think that started with Chef 15, and I can't remember which version of InSpec. So even though the source code is open, if you needed to use that, it does require forking that source code and removing trademarks. But all of our builds today and moving forward do require that commercial relationship.
All right, great. One that came through here in the chat, does Chef provide a cookbook to apply CIS benchmarks?
So good question. There are, so just to kind of cover what we do today for CIS is from the InSpec point of view, which is that read-only, we can measure CIS compliance against Windows and Mac OS and many other operating systems. To do remediation, we have started authoring those cookbooks. We've started on the server side. I know that probably the first one that's going to be released for remediation CIS on desktop is going to be Windows, because it's very close to the Windows Server remediations. So stay tuned, and at ChefConf we'll have some more announcements around what's actually going to be available.
All right. Another one here. What is in the Chef desktop product that will be coming out?
So yes, I did mention there is a Chef Desktop product coming out. I can't speak too much. I did kind of let slip that there will be a chef-centric dashboard, and then expect that some chef resources will, for desktop management, will go native, meaning they'll be built into the Chef client, and under full support from chef engineering and our support and architects, field architects teams.
All
But
right.
the announcements will be at ChefConf, and we'll have breakout sessions. I think 1 or 2 breakout sessions on Chef Desktop.
Another one here. What other zero trust tools let me measure compliance health?
The big ones are Okta and Google, and what I mentioned earlier is they typically don't do arbitrary types of tests. So like you couldn't invoke InSpec with those tools today. We're hoping that we can work with them and enable that. The types of compliance-based tests they do are things just like disk encryption and screensaver timeout. On the Windows and Cisco side, you can get to a point of invoking tools like InSpec, or actually I shouldn't say invoking InSpec, because really it's gathering data, device context data from the Automate API. That's really the key to this.
All right. And this might be the last one here. And it's pretty specific, but it sounds like somebody has used Chef a bit, moved to a local government org, and it's hard to get the initial resources to buy licensing. So how much of this can this person do in a dev environment that is not used in production before you have to ask for more licensing?
Okay, I'll prefix this with I'm not a lawyer. And if we can note who that was, we can send them the FAQ on that business model change that came up. But bottom line, our tools are available for experimentation use, but not in a dev environment in the context of I'm authoring code and the first place it goes is dev. And then if I'm happy with that code, then it moves towards production. But if it's strictly dev from an experimental, like we call our research and development area for new tooling, we call that dev, that's totally fine.
All right, great. And it looks like one more just came in here, just talking about, asking about our licensing. Is it per desktop or node?
Yes, it is. So yeah, it's licensed. Chef in general is licensed per node, so it's consumption based. We have bundles of I think 100 and 500 licenses, and desktop will be. I don't think we have desktop pricing online on the website yet, and we probably won't till ChefConf. But if you look at our retail pricing for server model, Chef Desktop will be less than that.
Okay, everybody's just finding some more questions here. So another one, is there a chef blessed, in quotes, benchmark for Kubernetes and Docker?
Can you read that question again?
Is there a chef blessed benchmark for Kubernetes and Docker?
I'm not sure what Chef Lest is.
It's like, they're just saying it like approved, maybe.
Oh, blessed, Chef Blessed for Kubernetes and Docker. Yes, so we have Docker. So CIS produces a Docker and Kubernetes benchmark for the server side where you're hosting the containers. And we have, I believe, converted that in. And maybe I can just take a peek at that and kind of break out of here. So on Chef Automate is where I go to learn what profiles exist, because every Monday there's more and more stuff because that's our update cadence. So let's just take a peek here. Kubernetes. Okay, so we have Docker currently, and we do not have Kubernetes. I don't know if that's because CIS hasn't released it yet, but maybe that's coming soon. And if I had somebody on the call from product, maybe they would know. But our intent is basically everything CIS produces, we produce InSpec versions of.
All right, great. I think we got all of the questions answered here. So yeah, we'll jump back in and just a reminder that ChefConf Online is happening June 2nd and 3rd, actually added some more content. So definitely check it out at chefconf.io. There's the agenda, the content, and we're running sessions actually in the weeks leading up. So on our blog, we're doing like an info week, InSpec, habitat, and you can join those as kind of a live audience. So definitely check that out. There's tons of great content that will be coming out of those. So definitely be sure to register. It's free, of course. So if you haven't already, just go to chefconf.io and sign up there. So we'll close it out there. Thanks again for everybody who attended. Look for an email for follow-up with the recording, and we'll close it out there. Have a wonderful day, everybody.